Beefmaster and the breeding value system. This simple course explains the breeding value system that is used by the Beefmaster breed. Gaining basic insight and interpreting the performance data will assist in improving your beef herd. The basic foundation to genetics is based on the foundation that offspring gets 50% of their genetics from each parent. The basic DNA test that used to confirm the sire or parentage is referred to as a microsatellite test. Somewhere between 11 and 17 predetermined markers are compared to determine whether the sire is possible or both parents are possible. The test thus confirms the parentage of the offspring. The genomic DNA analysis is a lot more complicated. In the case of a 50K test, there are 50,000 markers being analyzed. These markers can be used to analyze parentage, but also the relationship with many known markers associated with performance traits. This information is included in the performance analysis of the animal. The accuracy of the analysis of the animal can be increased much earlier in the life of the animal. Many other single gene traits can be identified with this test. Examples of these are polledness, color, and myostatin deviations. Stud breeders will mostly be testing their herd sires in the near future. The study of genetics is divided into two sections: the traits that are controlled by single genes or the traits controlled by a huge magnitude of genes. Mendelian genetics refers to the action of single genes. This form of gene action of simple dominance or recessive genes is named after Mendel, the man who first understood the workings of these genes. An example of such a trait is that of polled or horned. The mating of related animals is described as inbreeding. Stud breeders are motivated to this practice to promote uniformity and predictability of breeding. The reality of this is that it may well lead to a depression in performance. Undesirable recessive genes may come to the fore. As a practice, some stud breeders can use it in some cases, but it's not recommended for commercial beef farmers. Quantitative or population genetics is the genetic action where huge amounts of genes create patterns which influence specific traits. This normally includes most of the performance traits. These traits are normally measured on a sliding scale like kilograms. These measurements also tend to show the characteristics of normal distribution. Genetic progress is normally achieved by breeding with excellent animals and the culling of the poor animals. The simplest description of BLUP is an attempt to mathematically isolate the environmental influences on the performance of the animal, leaving the genetic component behind to see. This is the most accurate evaluation currently available of performance traits that we can use. We neutralize the environmental effect, the farm effect, the seasonal effect, and the nutritional effect. Once this has been done, we can estimate the genetic potential of the animal. Other animals in the pedigree contribute in different ways through the life of the animal. In the young animal, the BLUP evaluation is based on the parental average. The moment the animal starts getting its own data, the BLUP evaluation is more heavily based on its own data. Later in the life of the animal, when the data of its progeny starts being recorded, then this data will contribute more heavily to the animal's own performance BLUP figures. One of the foundations of BLUP is that an animal is evaluated within its contemporaries which receive the same treatment. An animal that weans heavily in a group that is weaning fairly light will show strong positive. An animal that weans heavy in a group that also weans heavy will show up as average. Make sure the groups of animals receive uniform treatment. If this is done inaccurately, there may be incorrect evaluations. In order to achieve accurate BLUP data in a herd, related animals in more than one herd are needed. For accurate BLUP data, pay attention to animals that link herds together. Measure all animals in each group. Guard against weighing only the good performers. This will cause the average to be higher than the actual average, and then good animals will show up poorer than they should be. Breeding values are usually expressed as, let's say in the case of weights such as weaning weight, are expressed in kilograms. In this case, the plus 10 will refer to 10 kilograms above the breed average. The accuracy of the figure refers to the reliability of the figure. Figures below 40% have a big chance of change. Figures above 60% accuracy have a much lower chance of changing. The breeding value index just makes it easier to express the same breeding value only in an index where 100 is the breed average. This is different from the old-fashioned indices that were used. These are based on breeding values. Estimated breeding values are expressed after a BLUP analysis on the data submitted from animals. In genomic expected breeding values, the standard breeding value is influenced with data from the genomic analysis, as in a 50-case SNP test. This increases the accuracy of the analysis much earlier in the life of the animal. The genomic analysis of herd sires may well have a positive effect on the general accuracy of the data in the herd. Here, most of the traits BLUP is worked out on are listed for each animal. Study your auction catalog or your herd list to better understand the numbers and then to make it a constructive part in all of your breeding decisions. Integrate the performance analysis into your other evaluations of the animals in order to make balanced decisions. Make balanced Beefmaster decisions to improve your herd.